To implement the actual memory ring buffer, the FIFO buffer, we're gonna use something called the FB memring buffer from the TC2 utilities library, which gives us the possibility to do this FIFO buffer. So if you read this does exactly this, what we need. The function block FB memring buffer can be used to write data sets with different lengths in a ring buffer or to read previously written data sets from the ring buffer. Exactly what we want. So the written data sets are read in the same order as they were previously written to the ring buffer based on the FIFO principle. The oldest entries are read first, which is exactly what we want. So we're gonna use this guy and make our event buffer is going to be based on it. So in our event buffer, we create an instance of this memring buffer. So we can be explicit here and say that it is in TC2 utilities, which we haven't added a reference for, so we need to do that. Utilities. So we have a reference to that. FB memring buffer. And then we can start by implementing the different methods. Let's start with the simplest first, get number of events. So to get that, we can look into the memring buffer, and as you can see, so the way it works, this memring buffer is that it's using actions, which is kind of like a method, but not quite. But you're accessing these different functionalities by calling these different actions. So here we have add tail, which is gonna add data to the end. Then a remove head, which reads and removes the oldest data set from the ring buffer, which is what we want. So we want to use this guy and we want to use this guy. But we also want to use this output ncount. So ncount here returns the current number of how do I pronounce this? Queued data sets. That's what we want. So that's what we're gonna return in our get number of events. Our get number of events is simply gonna return the FB memring buffer and count. And then that should more or less be it. The next one is add event. And for add event, we're gonna call FB memring buffer add tail. And what did add tail want? It wanted, so it always wants all of these guys. And with actions, we only need to add the stuff that's applicable, right? So for adding, we only need p write. That's the data that we want to write. The cb write, which is the number of data bytes. So that's also what we need, that we want to write. The read we don't need. That's what we're going to need when we call the other action, the remove head. And then we need a pointer to our buffer that we have created, which happens to be byte, which is very convenient because we also created it as a byte array. And cb buffer, which is the size of our buffer. Yeah, so let's do that. The p write, so we can remove this read. P write is gonna be the pointer to what we want to write, and that's address of our SD event, and the size of what we want to write is size of SD event. And our buffer, a pointer to our buffer that we already have, we have a pointer to our byte buffer here because that was provided when we created this object on object instantiation. So that's the pointer to our array buffer, and the size of the buffer is size of array buffer. And they happen to be the same type. That's very convenient. Then to know whether it was successful, we can always on the memory ring buffer get BOK here. That will give us the output of the last action call. Returns true if a new data set was added or removed successfully. Returns false in the event of a buffer over. Yeah, so that's exactly what we want. So we want BOK is mem ring buffer BOK. Yeah, this should be everything for the add event. Then we need to implement get and remove event, and then we will simply copy this guy. And instead of calling the action add tail, we're gonna call the action what was it? Remove head, that reads and removes the oldest data set. But now we're not gonna write anything. We are going to read data to somewhere, and we are going, how was it again? Yeah, we're gonna read data, and now we're gonna read it to this address, to wherever as the event is pointing to. And when we call this action, the output of the function block will be updated to the latest action call, so BOK will be provided here as well. And that should be everything for the buffer. So let's run our tests. Our tests will tell us the truth. They still fail. Well, actually 2 fail, 1 is successful. 3 events, expect all to be correct and successful. Why did this guy fail? Let's start with not this one, but add 4 events, expect all to be added except the last one. So why did that fail? The last one should have been added successfully. So where did it fail? Should have been added. Okay, that wasn't. Should have been added successfully. Okay, so let's add some extra. Should have been added successfully 3. Should have been. So one of these guys have failed for some reason. Let's rerun the test. The third one was not added, but the first and second one was. Why is that? So we add, everything I do is I add 1, 2, and 3 events. And 4, I mean the 4th is obviously not gonna fail. This is super weird. Is there something wrong with my calculations of the... Is there something wrong with the calculation of this? So size of will return in bytes. Let me think here. Size of will return the byte size of this event. So it will check how many bytes is this. And up to 3. I mean, I don't know. So for some reason it doesn't fit. And the only reason why this would fail is because the add event here failed. And the only way it could fail is if there wasn't enough space in the event buffer. I'm very confused. The only thing I can think of right now is that there is something. Yeah, this is something what I can think of. The only thing I can think of is that there is some weird internal. I mean, this is the problem. I have no idea about this guy, how it works internally, because as you know, if I go to a function block and I want to look at the implementation of it, I can't, because Beckhoff doesn't provide the source code to their libraries, which sucks, but okay, I can understand that. So I can't really look into how the internals are managed here, but I imagine that they need some internal space or something in the buffer to manage every event, something like this. So I'm just suspecting that we need slightly more for every event, because the memory ring buffer needs some internal space for every data that you put there, for every structure or for every data point that you put into the buffer. So I will just shoot here from my shoot from the, shoot in blind, so to speak, and add some extra bytes to every event. So let's just add 8 bytes. As long as we get our tests to run successful, I am fine. I will just add 8 bytes to every event, so we get a little more extra space. Or 4. Oh, I don't like 4. I like 8. Because I don't like 4, but I like 8. That doesn't make any sense. Why? Anyway, let's see. Okay, so now we have 2 successful tests. Yeah, exactly. So there is something with the management of when we do an add event into the memory ring buffer, then this function block memory ring buffer does something internally, so it needs a little more space or something. I have no idea, but the test is successful. So let's just leave it like that. And then I wonder whether the other tests actually let's store it in the same way. Whether they fail because of the same reason. So oh, hallelujah, as you say in certain places of the world. Ah, yeah. Awesome. Yeah, so our tests pass, which means that we have something that works, and we can use this for the rest of the code. Okay, now we can take this library and export it so that we can use it in our main program. I mean, this is, in the end of the day, this is where we want to use the project. So we have to export this as a library and use this library in the other program. Before doing that, I just have to set up some parameters. Actually, I can put, so I have my own company now, so I can put this guy, event buffer library version 0.1, and then we save it and install it, just as you've already learned how to manage libraries. And then we create a reference to that library here, event buffer library. And so far everything here should work just as it did before, because we're not using the buffer anywhere. So what we want to do is that we want to make sure that the event CSV persistent event storage uses this buffer instead of right now it only writes 1 event, as I told you before. I mean, we can verify that this is still working. If I remove let's stop the runtime. Let's just delete this guy. Let's run it. I add 5 events. And I get, I have to set this boolean to true. Chup. Still only get 1 event, so everything is as expected. Now we need to use our awesome, cool, and tested library. And to do that, we should make a change here in the CSV persistent event storage, because the CSV persistent event storage, which is actually also part of the library, okay, so that's fine. So where is it? Here. Because the CSV persistent event storage is, when we store an event, we just store it directly to a variable here. That's going to be written, but this is where we want our event buffer instead. So what the CSV persistent event storage needs is a reference to the event buffer. So we will create a reference to it, and then this has to be created when you instantiate an instance of the CSV persistent event storage. Then that will be provided to the function block. The event buffer will be provided. Let's just do that. Let's provide a reference to reference. No, not reference to. Let's just write FB event buffer reference to FB event buffer. Then we need to add an FB init. FB we're gonna set it to this event buffer. This event buffer is the reference that we're providing. So it's gonna have a handle to the event buffer, which it should use instead of this guy. So we can remove that guy. And now when we store an event into the CSV persistent event storage, we shouldn't do this. Actually, we shouldn't do anything of this, I realize. We just want to add the event to the event buffer. That's what we want to do first. So we have the event buffer, add event. That's what the user provides of our CSV persistent event storage logger. He has to provide the event. That's going to be stored into the event buffer. Then be okay. We're not going to do anything with that. In a real program, I would use this information and put it in somewhere in the system so that it's visible for either the developer or the operator or whoever of the system that should maintain this, and see that there's a problem. But we add an event. That's the only thing we need to do here, because everything else, let me think. Yeah, that's the only thing we need to do here, because everything else is in our wait for event. We don't wait. We now don't wait for someone to add an event. We only check, is there anything in the buffer? Because as soon as there is something in the buffer, then we can start to do all of this stuff. Okay. So that means we wait. Yes, we wait, but we wait for if our FB event buffer get number of events is bigger than 0. Then we go to file open trigger. Right? So we remember, this is executed in every PLC cycle. When something is added, when someone adds an event to our CSV persistent event storage, then this function block should detect it and start to write it to disk. So the next thing is that the eWrite state here should then go to file open trigger. So the next state, the one under here, then we open the file, we open it, blah, blah, blah. Then we get to write event trigger. Now when we create our CSV string, it's not from this old SD event written to file that we had before, the single one, you know, the single one that we only managed. Now we want to get it from the buffer instead, right? Because we added something to the buffer. We concluded that there is something in the buffer. Now we need to get it from the buffer. So we will get our event from the buffer, SD event from buffer. Yeah, this is much cleaner now. I'm really happy with this code, actually. This makes much more sense. SD event from buffer. This is our event buffer that we have written, that is tested. Get and remove event. SD event. Okay, so we actually have to put this guy here. We write it to SD event from buffer. And then obviously here, be okay. You should handle the error if we get an error. I'm not going to do that here now, but you get the point. Be okay, ignore. And then now, instead of using SD event written to file, which we don't have anymore, we use SD event from buffer. That's what we want to write. Yeah. So that's it. That's the only difference. We use the data from the buffer instead from the static single event. Now this is obviously not going to compile, because if you look at our main, so this is the library. We can check all objects. Can just quickly check that we haven't broken anything by simply running the tests. This is the wonderful thing with tests, that you can always run them. It doesn't cost anything. Just run the test and see that nothing has been broken. Okay, and then we install this library again. We go back to our main project. Now this is obviously not going to compile because CSV persistent event storage expects an event buffer. So let's create an event buffer. I just realized that I haven't been consistent with the naming. Sometimes I don't put a function block ahead here. Sometimes I do it, and yeah, my naming conventions have not been consistent in this example. I hope that you forgive me for it. FB event buffer. But to create an FB event buffer, we need, so let's just do this. We need an FB event buffer, and that is provided to the constructor of CSV persistent event storage, right? Because the CSV persistent event storage requires an event buffer. Then but when we create an event buffer, we need to create an array of, the storage, simply the storage. So just buffer array 0 to size of SDF event times 3. Let's say it's, or not 3, let's just do it very big, 10. And then, we also need this 8 bytes. I don't know if it's exactly 8, but that's what our test pass with, so that should be fine. And did I forget that? Like this, of byte. My brain is frozen now. We need the byte array, and do we need anything more? No, we need the byte array. But in the constructor for the event buffer, we need to provide, we can look at the event buffer. We need to provide a pointer to this byte array and the size of it. So that's pretty easy. We do that by address to the buffer array and the size of buffer array. I mean, every one of you knows that I hate magic numbers. So, I would normally, what I would do here is I would say something like, this 10 here, is, size maximum number of events, something like this, and put it there. And the same with this number, some n memory ring buffer internal extra spacing or something, int. This just to make life a little bit, does it have to be the same? Make life a little bit easier for the next developer after you that's going to look at this code, because he's going to look at 10 and like, what does 10 mean? Or what is this weird number 8? If you just put a tiny label on it, it's much better to do it this way than to put all these comments and stuff that people do everywhere. Yeah, and I think that should be it. So we have created our buffer array. We have provided that buffer array to our event buffer here. And we told our CSV persistent event storage to use our event buffer now, which the CSV persistent event storage does. So it provides the event buffer, and then it uses the event buffer both when we add an event, but also when we read an event. So I think that should be it. And now if I add 5 events, all 5 should be stored, because it's going to go through each and one of them. It's going to go, the CSV event persistent storage is going to read the first. It's going to check, is there any event in the buffer? Then it's going to open the file. It's going to do all the stuff it did before, write the event, close the file, and then go back to wait for event. And then when it's back to wait for event, it's going to see, but wait, there's more events. And then it's going to repeat this. It's going to repeat it until all events are cleared from the buffer and written to disk. To spice this up a little bit, I thought we're not just going to reuse the same event, but we're going to do 5 different events, or 3 events, or 5. Yeah. Event type 1, and scare event 2. You can keep everything else. Let's just create 3 events. Um, 44, this is scare event 3. And then let's add those 3. Okay. Let's run it. Before I do it, let me shut down the runtime, put it into config mode, remove the current events, just so that we can clearly see that they're created. Nothing here now. Log in. And let's run it. Okay, now I'll open it. Ah! The power of test-driven development. It's really amazing. It works. And if we do an online login, we will probably see that the event buffer is now empty. So event buffer, this guy should say 0 here. The CBN count is 0. Yeah. So this is basically what I wanted to show you with test-driven development. I mean, there's lots of other things I would want to talk about regarding test-driven development. And this topic can get quite big. I mean, it's already quite big. I realized that this recording is probably going to be the longest episode of all. I would want to continue talking about this. I could talk about this for hours with you, but I guess I would just have to create a separate course or just about test-driven development in PLCs. But with this, I have shown you that you can really adopt all the modern software development practices regarding test-driven design from the traditional software development industry into the industrial automation field as well. And I just want to mention some other things here. I mean, you've seen how the development of the software has constantly made us ask questions, right? That's the important thing, asking the questions. And because when we ask the questions, that's when we're going to do the discoveries, and that's when we're going to do our learnings. And the learning process, this is what I've constantly been talking about. The learning process, that's where the fun is at, but it's also the one that really pushes us forward and making good decisions. There's some other things here as well, and you probably didn't think so much about it, but if we go to these tests now, then any developer, I mean, I might write the software now, but I'm sure in 1 week from now or 2 weeks from now, I'm gonna forget how this worked. But by just looking at the test, I can see. So I can go into a test and see, if I add 4 events, then I expect all of them to be added except the last one. Okay, so that means that there's some limitations in how many events I can add here. And I can simply look at the test and see the behavior of the code, how I should use this function block. So this is basically live documentation of the software. I don't need any separate documentation. The documentation is written as code, which is really, really good because it's always going to be up to date and correct, because if it's not correct, it's going to fail. So this is something really, really, really good. Another thing is that you can make any changes to this code, and you can always rerun the tests. I mean, that's really amazing, because then you know if we will feel much more confident in making changes, because if you change something and you know that you can always rerun the test and see did my changes break anything. And this was just a simple example, but if you have a very, very big code base, then this is very, very good to be able to do regression testing. That's the point, to be able to do regression testing. You could take this a step further and imagine that all these tests could be executed on a build server. So whenever someone commits this code into the common repository, so to Git or whatever version control system you're using, then this build server would pull this code and run the tests automatically and report back whether there is some tests that are failing. And this is super useful. I mean, if you're a big team or something and you have many developers, a lot of code, the code base is growing, which it usually does. The code base just grows and grows. Then it's nice to have this instant automatic feedback of that something in the code isn't all right. Which I unfortunately won't cover in this particular tutorial, but I will for sure talk about it in the future. I hope with this that I've given you a little bit a little better feeling of what test-driven development is all about, and just pointing out here that it's not, the naming is a little confusing. I mean, it's test-driven development. Yes, that's true, you're doing development, but it's equally much test-driven design, because it forces you into designing software in a certain way when doing this. And that's, I mean, at least as a big gain, the design as the tests themselves. I mean, the tests are important, but the design is the more important, or I don't want to say more important, but that's equally important as the tests themselves. So yeah, I think that's enough for this part. This episode of this Twinkle 3 course is probably the most controversial of them all. I fully understand that TDD can feel very unnatural, and I can only say this because this was my first reaction when I started with it. I know it took me quite a long time before I got into the TDD thinking and made it into a habit, but once I got into the habit, the quality of the software increased drastically. Not only did the quality increase, all the code also automatically got documented, as all the tests describe the behavior of the various software artifacts. When handing over code to another developer, they could do changes to the code at any time and simply run the tests again to see that nothing had been broken. It's not just about making my life easier, it's also about making the next developer that's gonna take over after me, and the developer after that, and everyone else life easier. So remember that most of the time that a developer spends is not writing new code, but looking into and understanding existing code. I hope that this episode has inspired you to write software using the practice of TDD. This was the last episode in this course that talks about the technicalities of Twinkle 3. In the next episode, I just want to finish off this course with a few words and just some general thoughts. So see you in the next and last episode.